Hey guys, and welcome back. I'm starting a new series on functions, and on this particular note 18, I'm going to be introducing functions and their drafts. So stay tuned. Hey guys, and welcome back. Franck here. If you have not subscribed already, go ahead and do so right now. Otherwise, let's just jump right into it. The first thing I'm going to give you here is f of x equals to x squared minus 2. This is a function. You can think of a function as a machine, something that will take in input and give you output. So in my algebraic representation of the function here, f of x equals to x squared minus 2, x is our input, and f of x, sometimes known as y, is our output. And the most important thing you should know about function is that for any input x, you can have at most one output y, which means you could either have no output at all for any x, or you can have one maximum. The second thing you need to know about function is that you can represent them either by using an algebraic representation like I did here, f of x equals to x squared minus 2, or you could also represent a function by its draft. And on this particular note, I want to show you how to draft a particular function. What we're going to do is select a bunch of x input and compute their output. And this way we're going to have a bunch of points that we can plug into our plane and connect them in order to make a graph for this particular function. So to start with, let's consider these particular options for our input x. We're going to have x equals to -3, -2, -1, 0, 1, 2, and 3. And to compute our y value, all we have to do here is take those particular x and plug them into our function f of x. And what that means is wherever you see x in the expression that represents the function, you would replace it by the input value that you have and then evaluate it in order to get your y value. So for this -3, for instance, what you're going to have is -3 squared minus 2, and -3 squared is of course 9, and if you subtract 2 from that, you will get 7. We're going to do the same thing for -2. -2 squared is going to be 4, minus 2 will give us 2. -1 will give us -1 squared is 1, minus 2 will give us -1. And if you plug in 0, we get -2. And plugging in 1 will give us the same thing as plugging in -1, so we're going to get here -1 as well. The output for 2, it's going to be 2 squared minus 2, which is 2. And finally, the output for 3 is going to be 3 squared minus 2, which is 9 minus 2, giving us 7. Now, what you should know is that you don't have to limit yourself to this particular value of x. I've chosen them especially around the number 0 so that I can have a full range of numbers in order to plug them in. And so with those points figured out, all you have to do now is draw your plane, which is made up of the x-axis and the y-axis. The x-axis is going to be carrying the x input, and the y-axis is going to be carrying the y output. And so once you have your plane all figured out, then it's time to put in your points. You're going to start by putting in the point -3 and 7. So with -3 here on the x-axis, you're going to go up until you reach a height of 7, because the height here is given by the output y, while the position is given by the input x. So you're going to have your point here at -3 and 7. The next point, -2 and 2, is going to be right here. And then -1 and -1, it's going to be at -1 here with the height at -1, so it's going to be below 0. Next point is going to be 1 and -1. Then you're going to have 2 and with a height of 2, then 3 with a height of 7. Once you have all those points plugged into your draft, you can then connect them with a single line and you should be good to go. And so this particular draft here is a representation of this particular function from -3 to 3. Right? So if you wanted to have this function represented in a different interval, you have to pick points that fits inside that interval so you can have the representation graphically. So now you know that a function, which is a machine that will give you an output for any input you give him, but no more than one output, can be represented by either an algebraic expression like f of x equals to x squared minus 2, or you could also represent it by a draft, which you have here on the right. So how do you know whether an equation or a draft represents a function? Well, let me give you some examples here. So algebraically, what you want is to be able to have something in the form of y equals something about x. So if I give an example like x squared plus y squared equals to 1, and I'm asking you if this is a function or not, what you should do here is solve for the output y by isolating it on one side of our equation. So here we're going to have negative x squared on both sides, which is going to give us y squared equal to 1 minus x squared. And then taking the square root on both sides and considering the positive and negative side of our equation, we're going to have y equals to plus or minus the square root of 1 minus x squared. And as you can see here, for some of the x value you put in, you're either going to have y equals to the square root of 1 minus x squared, or you could also have y equals negative of square root of 1 minus x squared. So this means that for this particular equation, there's a possibility for you to have two different outputs, which you don't want for a function. So whenever you're solving for y, when an equation is given to you and you get two different options for what y should be, that should be a clue that this particular equation does not represent a function. Let me give another example here. And so if I gave you 2y plus x squared plus 1 equals to 0, to solve for y here, you need to remove the x squared and the 1 and push it on the other side of our equation. And so you're going to have 2y equals to negative x squared minus 1. Finally, dividing everything by 2, you will get yourself a y equals to minus x squared minus 1 divided by 2. And so since for this equation, for any x that you put in here, you're going to get a single value for y. There's no plus or minus sign next to our answer here, so we are good. And so this particular equation does represent a function. And so this is how you do it algebraically. Every time you're given an equation, you have to solve for the output, which in most cases is going to be the variable y. So now, what if you're given a graph instead, and you are asked to figure out if that graph is the graph of a function? Well, that's going to be a bit more straightforward, because if you go back to our previous example here, x squared plus y squared equals 1, if I try to draft this for you, this is actually the graph of a circle centered in the origin with the radius of 1. And so saying that you don't want any input x to have more than one output y is the same as saying that you want your function to pass the vertical line test. What that means is that for every vertical line you draw on your graph here, you don't want the vertical line to touch the graph at more than one point. And so if I draw one here, you can see that this vertical line actually crosses my graph in two particular places, which means that this particular x input has two y output value, a positive one and a negative one. And so what this means is that this particular graph does not represent the graph of a function. And for the example that we have here below, if I try to graph it, it's going to be looking like an upside down parabola below the x-axis. If you start drawing vertical lines here, you can see that any vertical line you're drawing would intersect our graph in exactly one point. And as you know, to be a function, any input x needs to have either 0 or 1 output y. So for this particular graph, you can see that your answer is yes, this graph represents a function. Let me give you two more examples here. If I have a graph like this one, you can see for this particular graph, if you draw a vertical line right here, you would intersect the graph in 3 different places. And so you can see that this particular graph does not represent the graph of a function. And let me give you one final example. If I were to rotate this particular graph, I would get something that looks more like this. As you can see, for this new graph that we've gotten, any vertical line that is drawn on the plane would only intersect with this graph at exactly one point. And so this graph does represent a function. Okay, so in my next video, I'm going to be covering graph terminologies. We're going to be talking about domain and range, as well as minimum, maximum, and so much more. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.